Hello, in this video I'm going to show you how to use the vernier calipers. Alright, as you can see here, the vernier calipers has a pair of jaws. It also has a pair of ears, and there's even a tail here. I can use the jaws to measure the width of my nose, and I can use the ears to measure the opening of my nostril. As for the tail, you can use it to measure the depth of your nostril. Just joking. So the jaws is good for measuring outer diameters. The ears, we use it to measure inside diameters. The tail is used to measure depth. So just insert it into a hole, and I think you can imagine how it works. So how do we use this instrument? So first, notice that there are two scales. This is the main scale, and this is the vernier scale, also called the sliding scale, because it can slide, you see. There's actually a screw here. If you tighten it, then you lock the slider. You can't slide it anymore. So when you want to make another measurement, just unscrew it. So the main scale provides a resolution of 1 mm, just like a meter rule. In fact, the main scale is exactly the same as the scale found on a meter rule. The vernier scale is the interesting one. So you look here, the vernier scale has got 10 equal intervals. 10 equal intervals. But these 10 equal intervals are spread over 2.9 cm. 2.9 cm. That means each interval is actually 2.9 mm. 2.9 mm. So now the zeroth marking on both the main scale and the vernier scale are exactly aligned. But each interval on the vernier scale is 2.9 mm. That means the first mark here is misaligned with the 3 mm mark on the main scale by 0.1 mm. Get it? And that means the second mark is misaligned by the marking on the main scale by 0.2 mm. And the third one is misaligned by 0.3 mm, fourth one by 0.4 mm, and so on. What does this mean? This means that if I slide the thing by 0.1 mm, then the first mark will become exactly aligned. Get it? If I slide it by yet another 0.1 mm, then it's the second mark that becomes exactly aligned, and so on. So when I slide the thing by 1 full mm, the zeroth mark will become exactly aligned again. And this is how we can squeeze out the 0.1 mm resolution out of the vernier calipers. Get it? It's quite clever, right? So for example, let's look at this reading here. From the main scale itself, we can tell that this is 2.4 something cm. 2.4 something cm. So what is that something? For that, you look at the vernier scale. So which is the marking that's aligned with the main scale, or most aligned? It looks like it's the fourth marking, right? It's the fourth marking that's most aligned. So this measurement here is 2.44 cm. Get it? Now, what about this one? First, we look at the main scale, right? So from the main scale, it looks like it's 1.7 something. 1.7 something cm. Now we look at the vernier scale. Which one is most aligned? Looks like the eighth marking, The eighth marking is most aligned. If you want to avoid parallax error, you should position it right above your eye. See, that's the difference between theory papers and practical papers. In theory papers, everything, all the pictures are very clean, perfect one. But in real life, all the markings have certain thickness, and there can be parallax errors. So look from, just put your eyes above every marking directly to avoid the parallax errors. So it looks like, it's the eighth mark that's exactly aligned. So this has got to be 1.78 cm. 1.78 cm. Easy? Okay, one more example. What is this measurement here? Well, it's pretty close to 1 mm. It's very close to 1 mm. But is it exactly 1 mm? Look at the vernier scale. Looks like the first marking here is most aligned. It's more aligned than the 0th marking. So this is 1.1 mm. 1.1 mm or 0.11 cm. Alright, that's all. Ta-ta.